So it says consider the function f below. And I have f of x is equal to f raised to the x minus 6. Determine g, which is created by shifting f up 5 units. So what we're going to do is we're going to create a function g that is the same as this, but it goes up 5 units. So let's graph this on our graphing calculator. So what I'm going to do is I'm going to graph on my graphing calculator the original function. So turn on your graphing calculators, everybody. Go to y equals, clear that out. Everybody grab a calculator, turn it on, hit the y equals button. And I'm going to enter in 4, hit the caret symbol right here, to the x, hit the right arrow to kind of get out of there, and then put minus, what was it, minus 6? Yeah, minus 6. Minus 6. And for those of you in the back of the room, if you can't see what I'm doing, guess what? Wha-bam with the bacon sizzle, this is what it looks like. Right there. Okay? Do me a favor, hold your calculators up so I could see that you kind of have what I have. All right, cool. Now let's hit zoom. I think we could do a standard fit on this. So if I hit zoom and I go down to option number 6, or it says standard fit there, and I hit enter, well, bam, with the bacon sizzle, this is my graph. And there's that. Now what they want me to do is they want me to shift it up 5 units. So how do you think we do that? Well, g of x represents the y value. What they're essentially saying is take f of x, whatever that y value is, whatever the y value is, and increase it by 5. And then you say, well, how do I do that, Mr. Adams? You literally put in f of x, which is 4 raised to the x minus 6. That's this stuff right here. And then you're just going to go ahead and add 5. What's negative 6 plus 5? Negative 1. Good, thank you. So guess what g of x is? Negative 1. So how do I verify that? Take a guess. Graph it. Very good. So I'm gonna open up my graphing calculator and I'm gonna jump in here. I'm gonna hit y equals again, and I'm gonna verify. I should just fix this. I keep skipping this. See, I did a problem with another class, and I changed the line to like a dotted line. And let me change the color to green. Blue, red, black, magenta, green. And then I'm going to change this to a straight line. Almost there. There it is. And now I'm going to enter in 4, hit the caret symbol, raise to the x. And what am I checking? What do I put next? Negative 1. Very good. Thank you. So I hit graph. And guess what? That green line is exactly 5 units higher than the red line. But I want to show you something, and I want you to participate with me. Hit trace. Hit this button that says trace. Okay? Now, if you notice here, x equals 5 or 0, and y equals negative 5. Now, if you hit the up button, that y value is exactly 5 more than the other y value. Let me show you another example. Move to the left a little bit. Or really move to the left. Like really, really move to the left. I'm going to say like go to like -5 for x. Now notice that I'm pretty darn close to 1 here, -1. Well, guess what happens when I push the down button? Now I'm pretty darn close to -6. What's the difference? 5 units. Enter in 1 for x. You just got to hit the button 1, hit enter. What is my y value here? -2. Now, before I hit the up cursor, what do you think the y value for the other graph will be? Should be -2 plus 5, which is, what's 5 minus 2? 3. See? Pretty darn close, right? It's off a little bit because I'm not at 1. If I hit 1, it's exactly 3. See how that worked? So that's where we get this. Let me take a screenshot of this. That's where we get this f of x plus 3, because really we're taking the y value of the first function and we're adding 5 to it. And then we could do that to the equation as well, okay? So let me zoom out. I'll leave that up there for just a second so you guys can finish writing it down. Are there any questions on this particular one?